Hey, what's going on, guys? Kikins here. In this video we're gonna be sorting the moves scored by the ScoreMove function. So as far as we only have the captures getting scored, that's the only type of moves that we would be sorting, but the idea behind the sorting algorithm doesn't really care about which values are we sorting. That's the matter of either ascendant or descendant order, and we would be scoring and we would be sorting moves in descending order because that's the exact order we need in order to put those moves that potentially might provide some beta cutoffs earlier. We want to sort them at the very top of our move list. Well, okay, so let me just start implementing the sort move function code, and it would start getting even more clear quite pretty soon. So I just want to open the terminal in the current working directory, and by typing make debug compile the source, and if it compiles, run this BBC executable. So now here we print the move list before it was sorted. Now we'll create the sort moves function, and then we'll print the move scores again, and we'll see the difference, like how these moves would get sorted eventually. So let's actually start. So here, just right after the score moves function, I want to create the sort moves in descending order function. So this would be static inline integer called sort moves. And okay, let me think. So it would probably need to, yeah, it needs to take the moves pointer move list, yeah, just to be able to work with moves and with the scores. Okay, and again, like the way I'm supposed to be implementing this sort of a function right now is just a proof of concept, just to make it work. And obviously it's not the fastest implementation, probably it's the slowest implementation possible, but nevertheless it worked. Nevertheless it works, and still it gives quite pretty cool results at the very end. So again, this is another place where we have a big field for the further improvements. But again, bearing in mind that the main goal of why am I doing this is the didactic purposes, and also I want to show not only the current implementation of a chess engine, but the entire process of development progress. So that's the reason for first trying to implement things as simple as possible, and then improving, obfuscating, sophisticating the code, the ideas, the implementation, just to make it faster and stronger. Well, obviously trying to keep the guidelines of making it still both didactic and modular, which is my main goal here. But nevertheless, so I just want to give you an idea that the way I'm supposed to be doing this just right now is the most basic way possible, but even this basic way works quite pretty well. So without further ado, let's actually start. So the very first thing to consider, I want to score all the moves within the move list, and in order to do this, I want to define the move scores array. So this would be the integer, let's call this move scores, and now the size of this array would be taken from move list and count like this. So how many moves we have, that's the size of this sort of an array. So just to give you an idea. And now we want to score all the moves. Score all the moves within a move list. So this is done in a very simple way. So we just need to look over all the moves available. So for count, oh sorry, what am I doing? For in count equals to 0, count is less than move list count, and count plus plus. Okay. Yeah. So sec, guys. I'm just trying to figure out, so why did I, so it's probably wrong to say less equals. It probably should be just simply less than. Yeah, count less than move list, or I dropped the very last move, right? So that's, yeah, less than move list count. I'm sorry. So here is a little bug from the previous part. Hopefully I've seen that. So it's less than move list. It's not less equals. Okay. Well, here it doesn't really it's not that bad because we just don't print the last move. But here it's also not that bad because the last moves are usually not getting scored at all. But still, just to make it clear, so less, not less equals, but just less than move list count. And here, yeah, we just want to score move. That's it. So I'm calling the ScoreMove function, and move list just to pick up the move itself. So move list, and I'm sorry, move list moves indexed by the count. And so this is the value, so this is the score, and now to assign this score, just want to assign this to move scores, and indexed by the count, yeah, like this. So if I now print this move scores, this should be the same. This should be the same as the data we have here in the output. So let's just print this move scores count. So, well, I can actually grab this code, and that's it. So just to make sure it works, it does give the proper scores, but not the move itself, but instead I want this move. So it's literally the same, but just to make sure it works. So sort moves is not yet being called, so print move scores. Let's call the sort moves routine here, so sort moves, and pass in the pointer to the move list like this. So let's have a look. It should now print to absolutely the same. Oh, it just didn't print a new line there, so let's provide that as well. ScoreMove. Yeah, let's just give it a new line, give it a couple of, just to distinguish. I'm sorry. Just to make sure they are the same. So 0, 105, 105. Yeah, 1, 2, 3, 4, 5. Yeah, so it seems like it's correct. Okay, so now we can get rid of this part, and from this part as well, and now the sorting algorithm itself. So first we need to loop over current move, so that's the matter of shifting the move counter, and we will have two nested loops. So first we want to loop over current moves, or yeah, let's say loop over current move within a move list, and the next one would be to loop over next move within a move list. I hope this would get quite pretty clear now. So I can simply say like for, and I'm using, so instead of this count, I would be using current and next counters. So current equals to 0, current is less than move list count. Okay, and current plus plus. And now the same, but instead of current, I would be using the next, like this. So int next. Well, we can even say like current move and current move to make it even more clear. So current move, and here this would be the next move. Next move. Next move, and increment the next move. Well, and obviously here we say current, so current index but plus 1 like this. So this would be the next move. So this is the core idea behind it. And this is it. Now we need to compare current and next move scores. So we can say simply like if, and so referencing this move scores of the current move is less than move scores of the next move. In this case, we will simply need to swap the scores and swap the moves. So that's it. Swapping the scores is needed in order to reference the score properly later on, and swapping the moves actually replaces the moves within the move list respectively. So to make sure that those moves that has to be scored greater are put first, and then those moves that we don't really care that much about. So we need to swap scores, and we want to swap moves. So in order to swap scores, so we need to so current should be equal to next, and next should be equal to current. But first we need to create so-called temporary score to store the current, because if we just rewrite the current score straight ahead, we just lose it. So temp score would be equal to move scores, and indexed by the current move. And the next step would be to say move scores current move. So as far as we did preserve the value of the current move, we can now already override this with a better value. So it would be equal to move scores indexed by the next move, and then then move scores next move would be equal to temporary score. So the bad score, the worst score, is becoming the next one. So if it's better, then it stays there. If it's worse, it's just going down, 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 and so on. And now exactly the same should be done here with the moves. So also I want to create the variable temp move, and it would be equal to well, I'm just wondering, yeah, I would better not create the move variable just to make it a little bit faster. So I just want to say move list moves indexed by current move. So current move is getting preserved, and then move list moves current move should get replaced with the next move, Okay. With the next move, and then next move should be replaced with a temp move. So the same that we've been doing with our scores. And if I did everything correctly, this should kind of work. So let's try to compile and run the source. Okay, current move. 2497. Okay. Okay, and now let's try to test this. So now we print only the initial scores, okay, and now let's print the scores after the sorting algorithm applied, and hopefully we have these values being sorted appropriately. So we have now we have the move e2 takes a6 as the very first one, which is a good idea because we just recaptured the bishop. And well, so I will now just drop this initial scores from unsorted list just to have a quicker access to the board diagram to show you the moves. So e2 takes a6, so bishop takes this bishop the first move, then f3 takes f6. Yeah, it's not a good idea because this would lead to losing a queen, but as far as we don't yet have so-called static exchange evaluation, which is another improvement to the move ordering of captures, this move is scored better because the other moves, like say g2 takes h3, is scored less, and that's the reason. So let's consider that this knight is not protected because MVVLV has no idea regarding whether the piece is protected or not. So assuming that the piece is not protected, it would obviously be a better idea to take a knight rather than to take a pawn, because you will win the material. But unfortunately, MVVLV doesn't see that the knight is protected, so he generates this move first, and then he generates this pawn capture. Well, this capture, when king is capturing either this queen, either this knight or this pawn, should be the very last capture because both leads to losing a queen. So that's the reason. That's kind of some sort of a teaser to encouraging us to implement static exchange evaluation. But I think this would be done probably later on within the probably the second version of the engine, because I want to keep the very first version of the engine as simple as possible and as modular as didactic as possible as well. Probably, I'm not yet that sure, but probably even the transposition table would already be like within the second version. Well, obviously, it's not the matter of absence of these topics in the video, not at all. I just want to bring the entire engine to some sort of a state where when it already is capable of kind of playing chess versus other engines, taking part in the tournaments, and maybe even get some initial rating. Well, doesn't really make that much sense to me, but still. So when you have the initial version, you have something to compare your further versions with, and that allows you to go for a scenario where you're just making some improvements to your chess engine, and you're making it play versus its previous version, and you see like it's stronger. It kind of starts winning from the previous version, and that's how you know that you have improved, basically, especially regarding to evaluation. So that's kind of it. Well, nevertheless, so then we have this taking the knight move. Okay, then we have pawn takes pawn, so g2 h3, d5 e6, d5 c6. Well, we take to c6 because of setting up this in peasant squares. So let's get rid of this. I just wanted to show you guys that this evaluated as pawn is as pawn takes pawn, which is the good idea basically. Okay, so now let's drop it because we don't really have that move in there. So d5 e6, g2 h3, e5. So now knight takes pawns. So knight takes g6, d7, and f7. So here knight takes d7, e7, and g6. And this again, like assuming that pawns are not protected. Yeah, so obviously we'll lose a knight in any of these cases, but assuming that if the pawns are not protected, so how it's scoring? It scores that if you take a pawn with a pawn, it's better than if you take a pawn with a knight. Why? Because pawn is a less valuable attacker compared to the knight. So knight is kind of more valuable attacker. That's the reason why this move is scored less. So that's just the idea behind the MVVLV, most valuable victim, less valuable attacker, and how it works in particular, how it sorts the move. But already with this sortings, the amount of nodes being saved during the search is really significant. So that's actually what I'm going to show you guys within the next video. So in the next video we will apply our move ordering. We will embed our move ordering within within our search, basically, both Nigamax search and the Quiescent search, and you'll see how better it would be after. So yeah, that's it. Okay guys, so this is it from my side. I hope to see you in the next video. Hope you've enjoyed this tutorial and learned something interesting out of it. I'm waiting to see you in the next part. Until that time, and take care.